Hello, everybody. Today we have a problem from AMC 2001. This was problem 21. Now, I chose this problem because it has some magic to it that will give you a kind of enlightenment, like Satori in Japanese, and you will have one of those aha moments. Okay, so let's look at this problem. Now, what we have is a system of three equations, a times b plus a plus b. There's four unknowns in these three equations, and we have to solve for all of them. We're given some side conditions. A, b, c, d have to be positive, and the product of all of them, this turns out to be very important. The product of all of them is 8 factorial. Okay, now the interesting thing about this, or one of the interesting things about this, is that it seems like an algebra problem. So is this really an algebra problem? Are you tempted to start substituting things into these equations or multiplying them and simplifying them or factoring them or whatever? Yeah. I know it's tempting to do that and go off into the weeds, but it's actually not so much an algebra problem, not really. It's more of a number theory problem. And it's an elementary number theory problem. There's nothing sophisticated about it. It's really a problem about divisibility. Divisibility. Can I spell this problem? Divisibility. Wow. Let's try that again. Divisibility was, when you write a word for the first time, like vertically like this on a computer, it can really throw you off. Okay, so all right, and let's see how this is going to work. If you start thinking of this as an algebra problem, you're going to go maybe in the wrong direction. And instead, let's think of these conditions first. So think number theory, divisibility and number theory, because we're told here a condition about divisibility. A, B, C, D must all divide 8 factorial. Well, there is a little bit of algebra to this, and the first and maybe only bit of algebra we have is that we have to recognize something. I'm sure you've seen this identity, or this. When you multiply these two out, you get xy plus x plus y plus 1. Now, this is really important because it happens often, and it's good to know. So when you see something like this, you know you can factor it that way. But we have something very similar, very close. We have this. Well, it turns out that this is close enough because we can do something like this. A plus B, or A, we can add 1 to these things. So A, B plus A plus B plus 1. And now this is going to be A plus 1 times B plus 1. But I have to add 1 to the other side, 525, like that. Very good. So we can do this now. We did it to this one. Now let's do the second one. So BC plus B plus C, add 1 to the left-hand side, and we get B plus 1 times C plus 1 is 147. Now CD plus C plus D plus 1, that's C plus 1, D plus 1, and we must add 1 to the other side, like that. So since this is about divisibility, let's factor these things. We have a hint, that this is about number theory in a sense. So what do you do when something is about number theory? Well, you factor. So 525, the factoring of this is 3 times 5 squared times 7. I did that using a program called Maxima, which I use all the time. I use it in the background when I'm doing stuff. And also I use it for all my work and for everything else that I do to check what I do. Of course, you can't use this on an AMC competition, but well, there's a lot of students that are really good at factoring and arithmetic and all that. I'm not, so I use Maxima to check my work. Sometimes I am, but often no. But I will get around to talking about Maxima and doing demonstrations of Maxima, because Maxima is really, really cool. And here's a couple of reasons why it's cool. It's free, and it's really convenient, because you don't have to use one of these notebook interfaces or anything like. You don't have to do that. You could just run it off the command line and get your answers instantly. So you can check all your algebra, all your integrations, differentiations, all your number theory stuff. You can check that with Maxima. Just drop into a command line and instantly do it. So I will get around to talking about this. It's really fun to learn Maxima. It's been around for a long time, and I really recommend it. Okay, 147. Well, 147 is 3 times 7 squared. And 105 is one of those square-free numbers that Mobius really liked. So that's 3 times 5 times 7. Okay, very good. So now comes the logical thinking part. So we're actually done everything involving algebra. There was very little of it. And we're really done with the number theory. There was also very little of it, just factoring. But we're almost done with the numbers. We still have a few steps. But what we're going to do now is logical thinking using our brain. Okay, so these things, let me highlight these things. So we're going to work with these equations here. Okay, and let's look at them carefully. So you notice that this one, the first one is different from the second one, in the sense that it is divisible by 5, but the second one is not divisible by 5. So you have B in common here. Okay, so since there's no factor of 5, there's no factor of 5 in C plus 1, there's no factor of 5 in B plus 1. So if there's no factors of 5 in B plus 1, all the factors of 5 must be in A plus 1. You get it? Okay, all right, so let's write this down. So let's reason from equation 2, we can deduce that 5 does not divide B plus 1. And I hope you're familiar with this symbol. This symbol means vertical bar means divides, and vertical bar with a little stroke through it, that means does not divide. Does not divide. And they're very, very handy. You see this in books on number theory all the time. So 5 cannot divide B plus 1 because there's no factor of 5 here. And 5 cannot divide C plus 1 because there's no factor of 5 there. And so therefore, from equation 1, it must be that 5 divides A plus 1. There's no other way for this factor of 5 to appear. It can't come from the B plus 1. It has to come from the A plus 1. And since the only place that has 5s is in A plus 1, all of this, 5 squared, 25, must divide A plus 1. 25 must divide A plus 1. So this is our first really big result, from which we, with a little more thought, we will now be able to find the value of A with a bit more thought. Right. A bit more thought. And let's look at the factors of this. So 5 divides a plus 1. 25 divides a plus 1. So let's look at all the divisors of the right-hand side here. So what are the divisors of 525? So we're going to look at all the divisors and then make some judgments about this. Well, I'm going to use maxima to find the divisors. And I'll show you next time in another video how I'm doing that. But right now I'm just going to write them down. 1, 3, 5, 7, 15, 21, 25, 35, 75, 105, and 175, and 525. Okay, well, which ones are divisible by 25? So I'm looking for a plus 1. What is a plus 1? Well, a plus 1 has to be divisible by 25 because of this here. So that's possible, that's possible, that's possible, and this is possible. However, if you recall, we had this condition here. Okay. And let's keep this in mind. That means a must divide 8 factorial. Okay, so let's continue here. So, but, let's make a note here. But a must divide 8 factorial. And let's see if any of these numbers divide 8 factorial. If you use a calculator, you will see that, okay, so a plus 1 can be 25. That means a is 24 in this case. And that is okay. 24 divides 8 factorial. A plus 1 is 75. This gives me a is 74. But this is not okay. 24 does divide 8 factorial. But 74 does not divide 8 factorial. Likewise, a plus 1 is 175. A is 174. No, this doesn't work either. 174 does not divide 8 factorial. And then finally, a plus 1 is 525. A is 524. This doesn't work either. 524 does not divide 8 factorial. You can check that with a calculator or with Maxima like I did. Or just do it by hand, which you would have to do anyway on an AMC competition. So we've got it. Okay, this is the only one that works. So we have A. A is 24. There's no other possibility. We've done it. Okay, very good. So now what is B? Well, we have all these formulas. We just plug this stuff in. So we use formula 1. Where's formula 1? So let's use this one. And we have a plus 1, that's 25 times b plus 1 is 525. Okay, so b plus 1 is 525 divided by 25. What's that? 525 divided by 25 is 21. So B is 20. Okay, let's write that neatly over here. B is 20. So we're making a lot of progress. We found 2 of them. There's 2 more, C and D. Well, let's use the other formula. Let's use the second one. Since we know B, so B plus 1 is 21. And now C plus 1, we want to find C plus 1. That's 147. Okay, great. And C plus 1 is then 147 divided by 21, and that's 7. And C is therefore 6. So let's write that really neatly. C, oh, okay, hang on. Okay. C is 6. Okay, really neatly. And now finally D. What's D? We use formula number 3, our third one. C plus 1 is 7. 7 times D plus 1 is 105. So D plus 1 is 105 divided by 7. What's 105 divided by 7? I hope it's divisible by 7. Okay, let's see. Yes, it is. That's 15. So then D is 14. Okay, let's write that neatly. D is 14. Put a nice box around it. And there we have it. We solved everything. And just as a check, why don't we do, just as an interesting check, why don't you try this? A times B times C times D. What is this? Okay, it should be 8 factorial. And what is 8 factorial? Just a minute. My magical maxima is going to tell me. 40,320. Now, so is this true? Why don't you try that as an exercise? Anyway, this problem is very beautiful because it is unexpected. You think it's an algebra problem, but the solution is sort of number theory and pure logical thinking, like excluding these possibilities here and then getting the results. I find it an amazing problem, and I'm in awe of the guy who came up with this problem, who cooked this problem up. It's very, very clever. But this is the nature of these competition problems. They're very, very clever. All of them merit study because they open your mind to ideas that you would never imagine before. So please like this vid and subscribe to my channel so that you can get more stuff and I can continue to make these cool vids. And I will explore all the themes that I talk about. I will gradually get around to exploring them. I'll do more Dirichlet stuff. I want to do a whole bunch of videos on Euclidean division and its implications and so many other things. Okay, thank you very much and see you next time.